One of the most important lessons to learn early is how to draw a good organic structure. Let's take a look at butane. Butane consists of 4 carbons, all singly bonded to each other. Attached to each of these carbons is a hydrogen. Carbon forms 4 bonds. This carbon only has 1 bond showing, and so it has to be attached to 3 different hydrogens in order to come up with the 4 bonds necessary. This carbon has 2 carbon-carbon bonds, so therefore it only needs to be bonded to 2 more hydrogens. Here has 2, this carbon has 3. Now, this is perfectly acceptable structure. Here's the problem with this structure though. It is really annoying to look at, and the last thing you want to do on an exam is annoy myself or the TA that's currently grading your exam. It won't bode well. And so, to avoid annoying us, it's best to draw these in sort of a standard notation where all of these carbons, all these hydrogens kind of get in the way of the basic structure of a molecule. And so, we're not going to draw in the carbon, the C, or any hydrogen attached to a carbon. Instead, what we're going to do is just draw in the bonds. So butane can be drawn like this. And it's just understood that each vertice represents a carbon. And so we only drew in the carbon-carbon bonds. So this carbon has 1 carbon-carbon bond, and so it's attached to 3 hydrogens. This carbon has 2 carbon-carbon bonds, so this is attached to 2 hydrogens. 4 minus 2 is 2. So on. Here we have another CH2. Here we have a CH3 at the end. Okay. You don't need to draw in the hydrogens attached to carbon. There is only one time in which you absolutely have to draw in the hydrogen attached to a carbon, and that is when you actually write a carbon as a C, like so. This is wrong. If you do draw in carbon as a C, you do need to draw in the hydrogens attached to it. So if you drew this middle carbon as a C, you need to add 2 hydrogens. If you drew the end carbon as a C, you need to draw in 3 hydrogens. Okay? You can draw butane like this. You could also draw butane like that. And that's perfectly acceptable. These are the best ways of drawing butane. Let's take a look at another one, dimethylamine. Dimethylamine consists of a nitrogen connected to 2 methyl groups. See how I drew in the C here? So I need to draw in the 3 hydrogens here. Now, this nitrogen forms 3 bonds when it's neutral, so it's bonded to a hydrogen. You do need to draw in the hydrogens attached to non-carbon atoms, such as nitrogen, oxygen, sulfur, and so on. So you definitely need to have this hydrogen in. So you can draw the molecule dimethylamine like this. You could also draw dimethylamine like so. Dimethylamine does have a lone pair. Okay. You do not need to draw in lone pairs on non-carbon atoms. You do need to draw in lone pairs on carbon atoms. So a carbon just happens to have a lone pair, you do need to draw it in. One example of carbon having a lone pair may be the cyanide ion. or this carbon has a lone pair on it, it also has a negative formal charge that you need to draw in. Two-pentyne. Take a look at that. Pent means 5 carbons, so we'll have a 5-carbon chain, like so, 1, 2, 3, 4, 5. The "-ine" suffix means there's a carbon-carbon triple bond, and that triple bond is located between carbons 2 and carbons 3. So we'll just draw in the triple bond. This is incorrect. The reason for it being incorrect is carbons 2 and carbons 3 are sp hybridized. Sp hybridized means a bond angle of 180 degrees. It's a linear bond angle. And this is not linear at all. And so to fix this structure, we really need to draw it like so, where carbons 1, 2, 3, and 4, these 4 carbons right here, the bond angle is 180 degrees. Now, we're not going to take a protractor and measure to make sure it's exactly 180 degrees, so you don't need to bring a ruler to an exam to draw in that. But it should be close to 180 degrees. 170 degrees should be close enough. Okay? But if it's something like this, where it's obviously not linear, then you're going to have points taken off. It's just the way it is.